Good afternoon, everyone. The House of Sultan and Sons Private Limited and methodAI extend a very warm welcome to all the participants of today's Artificial Intelligence webinar. It feels nice to have you all here, and we thank you for that. A bit about the House first. We are pioneers in the field of book publishing in post-independence India, catering to students from pre-primary to university level, churning out over 600 regular titles besides adding new ones to our stable year after year. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in reputed schools and colleges across the nation, as well as in some neighboring countries. Our authors are distinguished academicians, professors, and educationists with vast experience and expertise. We are proud to be associated with them. I now introduce you to the host of today's webinar, Dr. Sachin Gupta, author of Artificial Intelligence and Data Science books for classes 9th and 10th. Besides, Dr. Gupta is Dean, Research and Innovation, Maharaja Agrasen Institute of Technology, GGSIPU, Delhi. Dr. Gupta has also been HOD Computer Science Engineering and MCA Department of Dronacharya Group of Institutions, Deputy Director and Head of the Computer Science Department and Chandraprabhu Jain College of Higher Studies, affiliated to GGSIPU, Delhi. With a teaching experience of over 20 years, which includes teaching undergraduate and postgraduate students and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGSIPU. Dr. Gupta has also contributed to various journals, conferences, and books for schools and higher education, both nationally and internationally. His achievements are commendable. May I now request the man himself to take you through today's session, Dr. Sachin Gupta. Have a great day ahead. Thank you.
Thank you so much, sir. Thank you for the introduction. I'll start with the session very briefly. There are viewers on YouTube, so I request Ashish sir to kindly forward any query that are coming in there. And we'll just start with the second lecture in the series of artificial intelligence. The first one that we did was most about that what is artificial intelligence and what it is not considered to be. I'm just going to continue in the same series where we discuss that how is conventional programming different from artificial intelligence programming per se. I hope my screen is visible and audible. I am audible.
Yes, you are.
All right. Thank you so much. So I have already been introduced by Malik sir, thankfully. We have worked on a series of books in skill development that span across data science for class 9th and 10th. And on a very similar note, artificial intelligence that is this year released. And data is everywhere around us, how we are utilizing it, how we are bringing it to solve the problems that we are facing. That is so correlated between these domains about big data, about data science, about artificial intelligence, and several subsets that we keep hearing about that machine learning, for instance, and neural networks or deep learning, that there is some sort of confusion about what each of these domains constitute. How are they different? How are they overlapping? What is the extent of overlap? What is their dependence on each other? So that is the one thing that we are going to discuss today. And in addition, we are going to see that what traditionally programming used to be and how are we now taking it forward to a different direction with the abundance of data that we have. Before starting, I would just have to share one more thing that artificial intelligence or any related domain for that matter, be it data science, be it machine learning or computer vision, natural language processing, neural networks, deep learning, all of that have one basic requirement in common, that there has to be a lot and lot of data about the problem statement that we are going to discuss. So if we want to predict weather conditions uh, in a particular area or in a city or in a country, we should have a historical data about the weather conditions prevalent in that country for a very long period of time. If we want to predict the prices of a particular stock, then we should have a time series which should tell about the data of that stock, how this has been performing over the years. There should be a lot of data about it. So any of these domains would be data intensive. And by data intensive means that these systems actually learn from data. So coming to what conventional programming used to be, I'll just try to add in some more information. Our agenda for today would be conventional programming and subsets of AI, where what are the artificial intelligence? Yes? Did you say something?
No, sir. I'm muted.
Okay, fine. So we are going to test something for a minute before I take it forward. I wanted to see whether there is a whiteboard on my screen. I'll open a jam. Okay, here it is. So conventional programming, when I would say, I'll have a lot of time practicing with this thing. Doesn't work. Okay, leave it aside. I'll have to establish something else. So conventional programming, as we used to work with, was, I'll take a very small example. Prior, earlier there used to be programming models where we have to give the equation of, let us say, we take the example of converting time or converting Fahrenheit into centigrade. When we work upon converting Fahrenheit into centigrades, we usually have a formula that centigrade is 9/5 into Fahrenheit plus 32 or something like that. Simple steps of the programming would be that I would have to write a program for inputting the centigrade. I would have to apply the formula. I just simply take the output. So my steps are input, followed by process, and followed by output. So the process here was a mathematical model that we would be designing by ourselves as programmers. We give it to any high-level language program, and we give it the input data. It produces the output for us. That basically is how things work. Now, artificial intelligence, by definition, says that we want to replicate human intelligence in the machine. That means we want to have some process by which the machine would be able to identify what was the process, instead of we giving it the process that centigrade is 5/9 to F plus 32. Instead of that, what we do is we ask the machine to learn it by itself. We are looking forward for the machine to be intelligent enough to be able to deduce that if this is the centigrade, this is the Fahrenheit, then what is the relationship between them? That is the kind of thing that we are looking at. Now, this doesn't come intuitively. And this is in fact a mathematic equation. There are far more easier problems that come to humans very easily. Like you are trying to say, I want to decorate my home. I go out, I buy a set of flowers, and then when I come home, I know I have to put them in a vase, I have to water them. All of this comes from common sense. But would a machine be able to do it? Would a machine be able to understand what common sense is? So we learn common sense in a variety of ways, like trying things out, reading books, listening to instructions, even making mistakes, or let's see other people making mistakes. It's not a big deal. But what if there was no common sense? What if that humans could not learn over the period of time or by understanding their own mistakes or others' mistakes? Then let us say I bought a new big TV and I would place it on a simple cardboard box, not realizing that the cardboard box would not be able to support the weight of it. So if I see something brittle, I have to place it delicately and I have to place it on a surface which is hard enough to be able to bear its weight. That is common sense. If that was missing, we would have ended up breaking almost everything that we are bringing to our home. So common sense is intuitive to human by the virtue of our brain, but the machines, the common sense is not there. There is absolutely no common sense. They cannot. We are giving them in traditional programming that this is the input, this is the process, and this is the output that we are looking forward to you to create. So there is no common sense for that instance. Now, AI technologies are capable of doing some pretty amazing things that you can beat most experienced human chess players, as that was done in IBM Deep Blue. You can solve extremely difficult mathematical problems. You can even detect brain tumors with the help of computer vision these days. So AI is very good at doing a lot of things that are hard for most humans. I, as a human being, would not be able to try to replace a doctor in detecting brain tumors or would compete against a chess champion. That's not feasible for me. But AI struggles with some things that come very easily to humans, including the common sense, because it requires to learn more and more every time this is interacting with us. So there is a requirement of data that AI learns from, and it is only as good as the amount of data or the quality of data that we feed to it. So that is the basic difference between conventional versus non-conventional programming in AI. This was a very simplistic kind of understanding, but I'm going to elaborate it more with the what are the subsets of artificial intelligence so that we can see how data is applied to each of the domains, what are associated with, and in the process demystify what is artificial intelligence and maybe everything else that we have.
Sir, your voice is
And because there are a lot of please bear with me for a minute.
You're not audible.
All right, I guess I got my sound back. So let us understand how artificial intelligence subsets are working, and at the same time, how are they associated with the basic terminology. Starting with the first in the series, the definition of basic AI that we already understand is the computer system able to perform, or I would replace it. It's not just a computer system, it can be any device. It can be your mobile, it can be your wearable, any system which is capable of performing tasks that ordinarily require human intelligence. I'll call it a AI. It can be a program, it can be a robot, it can be anything for that matter. AI uses algorithms to train the machines to learn and process information. Now, there may be two parts to it that we have already known. The first part is that how do you interact with a system? So, I'll take the most common, most intuitive way that humans talk to each other, that we talk to each other in a language that we understand, the natural language processing. So, on your example, there is a device like Alexa. So you say, hey, Alexa, call Carol. Carol might be the name of your dog. Now, the machine learning algorithm built in Alexa is actually programmed to understand the human input, whatever you are saying, convert it into some language which the machine can understand. And then, after trying to match it with which name matches this particular person at the most, and what command matches the call most, it would be able to deduce that I have to place a call, a telephone call to Carol, the dog. That basically is algorithms in AI. And I have distinctly mentioned both things, that there has to be some input that can be NLP, that can be coming from various sensors, that can be coming from data across the website, that can be data from anywhere. But the easiest to understand is the natural language processor, the way we use to give command. And the second part is the algorithm, which is able to actually process the data that we are giving to it. Please post in any query that you have, or just simply open your mic and you would be able to place your question. So for AI, the first subset that we most commonly talk about is machine learning. Machine learning, in fact, uses statistics to find patterns in data. I began my session with an understanding that data is essential to learning in any artificial intelligence environment. How do different AI subsets use data would be differently placed. Machine learning works with, most of the time, works with numeric data, and it uses statistics to find patterns in that data. Now we'll come to this point also, that what kind of patterns are we looking for, because sometimes we know what is the data that we have. We know that the tabular interface, we know there is some relation between the data values. Sometimes we do not know anything about what is in the data. So statistics work both ways. It can find patterns in the data that we know nothing about, and it can actually use patterns to make predictions about the data that we know something about as well. Both of the ways. So let us take an example of machine learning when it applies to your YouTube or your Netflix or any streaming platform, where you understand that how do you predict that which particular song would be more interested, somebody would be more interested in. Let us say we don't know anything about the different kind of songs. We know only the genre of the song, and we have tagged the songs as per the genre, that this is hip hop, this is R&B, this is soul music, this is jazz, rock, or country, or Bollywood, or any kind of music that we have. So for a user, when they start playing on YouTube, they would be listening to some song, and YouTube can actually understand that how many times some particular song they are listening to. Over the time, the data points increase, the number of listens. So you can see that this area is having more number of listens. That means hip hop, R&B, and soul is the kind of music this particular person is more interested in, while jazz, rock, and country music are that they listen to them, but the frequency is not so much. So if we have all this data, how AI can benefit from it is, it tries to make understanding of what is the pattern here. That looking at this data point, I'll be able to guess that this particular number of items, the frequency here is much more as compared to this. So the number of listens is increasing when we are looking into soul R&B, and the number of listens is decreasing when it's jazz, rock, or country music. So what your machine learning algorithm would do, it would have all the data points. It is going to find out where is the maximum number of frequency occurring. That is the statistical figure of speech. And it is going to make song recommendations based on the songs in those genres which you have been listening to. All right. Now there are two things happening here. We had some data that you played music through your mobile phone, nothing else. Unknowingly, we are generating data that just by playing a song, we generated some data. How AI is actually benefiting from it is that they are capturing whatever data that you are generating. And in addition, they are feeding it to a machine learning algorithm, which is capable of identifying that where is the maximization happening. So accordingly, next time when you open YouTube, you will find your playlist flooded with all these songs across a different genre now. So this is an example of unsupervised learning. You are not telling anything to the YouTube video platform. You are just simply playing the song, and it is learning of its own because it knows only the music genre that you are playing. Those tags are available, and it is trying to capture that group which you were most listening to was belonging to the genres. We have not given any other information to our machine, just except that these are the data points. One more thing is happening here. The machine learning algorithm is plotting all these data points on a graph. We have a two-way graph only here. There is an x-axis, there is a y-axis. Music genre versus number of listens. So I call these things as characteristics of data. Characteristics of data as in that if I have to say characteristics of a student, they would be like, what is the age of the student, what is the class of the student, what is the number of hours they study, what is the number of hours they play. They all can be characteristics, they all can be features of the data that I am trying to collect, and each of them becomes a dimension in the data. So every characteristic that we can tabulate about a particular problem statement is a dimension. Here I have only two dimensions in the system of things. What is the number of listens versus what is the music genre, and the number of listens is also computed. It's not something that was available to us. This is something that the machine learning algorithm is calculating using statistics. So for any problem statement, AI converts it to a mathematical model or a graph which would be having as many dimensions as there are different characteristics of the data. So unsupervised learning happens when algorithms group data and find patterns on their own. So this can be like some students are chocolate lovers, some students love pizza more, some students love donuts more. So they can be different groups based on that. The algorithm would be able to calculate that this group is indulging in chocolate more number of times. This group always orders pizza. This group always orders donuts. So it can actually look at those points, plot them into a graph, then try to find patterns, and then able to predict something that if a new student comes and he's ordering pizza more number of times, then which category does he belong to? That is unsupervised learning. Any queries so far? Should I open the chat window to see? Okay, there is none. Then for supervised learning, it's a process of training algorithm to make predictions using testing data. I'll do the same thing. I have now two dimensions here. There is age, there is money spent. I believe both of them should be available to us. These are both the things that I'm going to feed to my machine learning algorithm, that on this age, I used to spend this much money. On the other age, I would spend this much money. But not just about me. this process would be repeated for as many number of people as I know, to make it more general, to make my algorithm learn more about people's spending habits. I would try to get it across cities, I would try to get it across villages, I would try to get it across different countries. And the more data that I can get, the more easily I would be able to find some relationship between these two. So what happens here, programmers give algorithms this data. Now, going to conventional programming. If there would have been conventional programming, we would not be able to find, we would be able to say, let us devise an algorithm. If age is 10, amount spent is 50. If age is 20, amount spent is 100. If age is 60, amount spent is 200, or so forth. So that if then else was the relationship that we would tell the machine that if the age is 10, then output the money spent is 50. So my input was clear, only the age. My output was clear, the money spent, but the relationship between them was defined by us as educators or as the developers. Now, if I do not have access to this relationship, that I just have access to this data, that all those people who have their ages and all those spending habits that they have, I do not know what is the relationship, what is the mathematical relationship between them. Maybe ऐसा हो सकता है that a person in the age of 20 is spending 20,000, a person in the age of 30 is spending only 15,000, and likewise. But I do not know what is the relationship between these two, what is the mathematical model that relates them. So what AI can do is, we can provide the entire data to supervised learning machine learning algorithm. We tell it these ages are there. That means each point is actually a correlation between these two things, that on this age, this point corresponds to what is the money spent and what is the age that they have. Okay. So we haven't told the machine that what is the relationship existing between these two. Now what I do, my algorithm is going to try to find the patterns in this data, that are they related somehow, that on this specific age people spend this much amount of money. Now there are several different people on the same age. Some people are spending more, some people are spending less, but I would be trying to find that there is some possibility of the data happening between these two things. So when a new user joins the website, let us say it was an e-commerce platform, the algorithm would determine that how much are they projected to spend based on their age. So they were in, let us say, age of 25 years. My money spent based on the relationship that I have identified, this would be, we would be able to predict that this person is going to be able to spend this much amount. Now, this relationship is derived by, this mathematical model is derived by the algorithm itself. We did not tell that on this age the person is going to spend this much. Now, this may be absolutely correct. The prediction may be absolutely correct. The prediction may be way off the mark, that I might be a 25-year-old who is an outlier, that I spend a very high amount of money, or I spend a very low amount of money. But this is only probabilistic, that on the average, a 25-year-old person would be spending this much amount. Even if we can capture that kind of information from this data pattern, our job is done. Good. That is an example of supervised learning, where I tell that the machine is told that this is what pattern we have already received. Try to find out a relationship between them. So far, so good. Now, let us say there were not two, but there were three factors. There was age, there was money spent, and then there was another factor, that whether you are living in a hostel or whether you are living at your home, that might be a third parameter. So instead of a 2-dimension, I would now have a 3-dimensional space, 3 different characteristics. I would have to try fit a line in 3 dimensions. So every time I add a different characteristic, every time I am adding more information to the system, and every time I'm making the system more complex. For 2D, we would be able to plot. We would be able to plot a line after drawing a graph. But think about 3D, 4D, 5D. What if there were 50 parameters on the behavior of a person? and we wanted to predict what is he going to do next, we would not. As a human, it would not be possible for me to do that. But for AI, perfectly fits because it enjoys working with data. The more data that we give it to it, the more pattern recognition it would be able to do out of that. So that is the beauty of artificial intelligence algorithm. I hope you understand supervised and unsupervised learning both. Any queries, please do feel free to put in. Now let us talk about another subset of AI, which goes into how to learn from more complex data that goes into neural networks. So neural networks are algorithms that mimic the operations of human brain. Now human brain does what? Let us say I was starting to learn cycling. The first time I tried to paddle, I could not balance, I fell down. I tried to pedal it while the cycle was standing. The second time I tried to paddle, I learned that I would be able to balance more if I am moving. So I tried to give a little push to the cycle and then tried to paddle. I could paddle successfully for half a minute and then I fell down again because my speed was very slow. The next time I could do it a little better. The next to next time I could do much more better. And eventually we learn cycling. We learn cycling to that extent that we can actually leave the handle off and we can drive it still anyway. So that is how our brain is functioning, that it's creating neural pathways on what we tried, what was the mistake we made, how did we correct the mistake, and then the feedback was given back to the brain again that this was the mistake, correct it, then try cycling again. Then again you generate some data, that data is tested again, then feedback is given again. That goes on and on till the time a pathway forms into your brain that this is how you cycle. Once that pathway is formed, you will never forget cycling or swimming or any other activity that you are doing for that matter. Now, if I have to mimic this by a computer, I would have to replicate three processes. There has to be an input. There has to be an initial process of starting. There has to be a process by which if I make a mistake, I learn and I come back and I correct it again. That's what neural networks do, in short. So neural networks have layers of artificial neurons that work together to produce an output. Now, how does this work? At the input layer, the training data is all sent through the input layer. This is the layer where we are going to provide input to a neural network, that what is the data that you are supposed to learn from. All the training data would be at input. The next is the hidden layer, where each node in the hidden layer is a mathematical function that based on this input, how to mathematically analyze what was my input. So let us suppose this was a person who was spending more, and I can actually through the hidden layer get the relationship between this person gender and their spending habits. For the other person whose gender is different, there may be different spending habits. So each of the hidden layer is a simple mathematical model that is calculating some aspect of this data. Over the time, there may be more complexity, there may be more parameters, there may be more number of parameters at the input layer. And you'll be surprised to understand that when I'm trying to process images, let us suppose my image is 400 cross 600 pixels big. Can you believe how many total number of parameters are we looking at? On the input layer, with an image which is having a resolution of 400 cross 600 pixels, it would be 6 cross 4, 24,100. That means 240,000 total number of parameters would be on the input layer, because each of the pixel is an input. So that is the kind of complexity we are looking at when we are trying to train the neural networks with images. But for easier problems where there are only 5 or 6 or 7 or 10 parameters, neural networks work very comfortably with a small input layer. So with the hidden layer calculating everything as a mathematical function, what happens that when the data is sent to the hidden layer node, the node computes the significance of the input. That is it significant that the person is male, that the spending habits are related to his being a male or his being a female. And after a while, after calculating the significance of the input, initially we assign some random numbers. We do not know what is the spending habits. We do not know how is it related to the gender of a person. But over the period of time, we give more and more challenging inputs, that if out of 100, 70 males are actually having this spending pattern, so we are going to tell the hidden layer ki, okay, this is a pattern that we are observing. Let us send it to the output node. That if the pattern of spending of more males, or over 70% males, let us say a threshold value is this, then if a person is spending this much and if his age is so and so, then he must be a male. There is a probability that this person should be a male. Similarly, for another amount of spending, if I find that over 60, 65, 70% of the females are in this spending habit, so this output can also be sent to the output node. What the output layer is going to do is, it's going to compute an output, that I find a new age, I find a new spending habit coming into the input layer, and the output layer, on the basis of what the hidden layers were telling, it is able to tell that the spending is so much, the age is so much. Based on my hidden layer, I predict that this kind of spending pattern, this much amount of money is usually spent by a female. So they predict that there is a 90% chance that this person is a female. That is the kind of thing that neural networks do. In case if it is wrong, you can always tell back, provide a feedback. So this process is repeated till the weight of each input generates an accurate output, or a sufficiently accurate output that we are comfortable with. Okay, give us 80% accuracy or give us 90% accuracy. If both of them work perfectly fine, I'm happy with 90% accuracy. Don't give me more than that. So once I receive the 90% accuracy, my training for the neural network may stop. In fact, at points, if the data is more complex, if I'm working with images, if I'm working with text, if I'm working with videos, then I can add more and more hidden layers to capture more and more information from the data that is coming in. So hidden layers can be added to solve more difficult tasks in the process also. Right. When we have a neural network with many hidden layers, they are considered as deep neural network, and the process is called deep learning. So from a simple machine learning where we were identifying data from the statistical patterns, just pattern matching, or learning from patterns within a small set of data which was available to us mathematically. Now we are moving to a model which is not even mathematical. Your images have to be converted to a mathematical function. Your voice or audio or video have to be converted to a mathematical function. But the more the complexity of data grows, the more we have to move from simple machine learning to neural networks to a deep learning where there may be more hidden layers learning from the data. That is the basic way how we move from machine learning, which was supervised or unsupervised, to neural networks to deep learning. That basically the distinction between the three different branches. But for all of them, one simple common characteristic is that conventional programming, we were telling the machine that this is the mathematical model on the basis of which you have to give an output. For artificial intelligence, any kind of approach, the AI is the one which is actually extracting the mathematical model which relates the input and the output together. So that was the same was true with machine learning, same was true with neural network, and same is true with deep neural networks as well. All right. There is another domain which comes in the subset, that is natural language processing. So here are the algorithms where the machines derive meaning from word and speech, like Alexa that we mentioned at the beginning. So let us suppose there is a small online help center where you post a query in a chatbot. Like having a really hard time figuring this out. There is an AI problem, or there is my PC has a problem, or my printer has a problem. I am not able to solve it. So NLP can extract and classify the text. Now, classification is a machine learning problem. Remember that if this kind of word is coming, then it must be this particular branch of classification. If some other set of word is coming, it would be some different class of problem. So urgency from these words, I would be able to identify that there is a 80% or 95% urgency. This NLP does. Similarly, the machine is now going to provide an appropriate response. But how does it provide the response? There's another good example to see here. NLP processes can extract and classify the text. Done. I'm curious about this. I like to learn more. There is the urgency of 30% and 25% respectively. Now, you provide a response. The machine provides a response, and you ask the user to give a feedback. Did you find this useful? The feedback button is available on ChatGPT. The feedback button is available on any chatbot which you interact with in the natural language. Even the Alexa, when you say tell it to do something and it does something wrong, it asks you to correct it by giving feedback. So this feedback is used to learn more. The machine tries to learn from the positivity of the response, and this again is a machine learning model that based on the particular type of response, it would try to moderate the NLP or change the responses to some different work. That is again another way how machine learning works. So I'll take a small example of or a demo for NLP, which you can try at your home as well. Okay. I'll open Wikipedia and dangers of AI. This is an article that I want to actually learn something from or extract information from. So you see, there is a small article. I have the link to this article here. I have a IBM Watson natural language processing generator where I can either input text or some URL from which I want to read information, and we give it this link and we ask it to analyze the URL. All right. It would take a while, but the process would be the same. There is some algorithm running behind that scene. The algorithm is trying to extract information, classify information. So see, there is a button for extraction. What entities are there? What keywords are there? What is the relationship between these words? This part is extraction. Then comes to classification. So for the entities, looking at AGI, it's an organization. Bostrom is a person. Geoffrey Hinton might be a person. OpenAI might be an organization. So it's just simply extracting the data from the article that we have, and with some degree of confidence, it's saying that this person, this might be a person, this might be an organization, this might be a number. All right, this might be a date or a year with some confidence. So Future of Life Institute is saying 0.97. There is a 97% probability that this is a institution. And likewise for each of, or for computer scientists, there is a 88% possibility that this is a job title. And like that. Then it goes to keywords, that these are the keywords that we have associated with this article. And what is the relevance of each of the keywords? Right. Then it goes into what is the concept in this article. It's more like artificial intelligence, super intelligence, emotion, reason, computer science, and research. And then the relationship between the different words that it has seen. Going towards classification, what is the overall sentiment of the article? It's negative. Then for each of the different, Geoffrey Hinton is very positive about AI, OpenAI is very positive about AI. So these are something that we can actually understand on why these people. So Elon Musk is very positive about AI. All right. So there is a person, Toby Ward, who is very negative about AI and so forth. But this is all of this information is, there was NLP that give it kind of data, break the data, convert it into a mathematical model, try to extract patterns from it, and based on those patterns, try to learn that all is working in the form of AI. So this was about that how my system is learning from different domain. I'll throw the floor open for any of the queries from the people who have joined us today from both YouTube and on the Zoom platform. Please ask any question. You can post any problem statement that how are we going to convert this to what was the conventional way of working with it, and what if we were to apply AI, then what kind of data do we require, or what kind of information it is going to extract. Put out a problem statement and let us solve it interactively right away. I am looking forward to any problem statement that you want to come across with, that this is a problem. How can we apply AI to it, or what kind of data would be required, or where do we get the data? Anything for that matter, any domain, that would be good. You can open your mic if you want to share something, or you can use the chat window to share information again. Any questions, in fact, are most welcome, along with. Ashish sir, are there any questions on the YouTube channel?
None, sir. I think we can close the session.
I am not getting any questions at all. I hope I am still audible.
Yes, you are.
No. No, 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 no. Just wait a minute. Just a very short minute. I have to check my Bluetooth settings back. Okay, Deepa Shankar is saying that I have to create an application to track the human brain for malicious growth. What kind of data would be needed? Okay, Deepa. From your query, what we can deduce is that the very first thing, we have to be able to track the human brain for malicious growth. What do we have available here is that we always have available, or so far our basic way of working is MRI. So we would require a lot of MRI images to see that whether or not, or in fact, we'll have to have a lot of images of healthy people, their brains are healthy, and a lot of MRI images of who already have a malicious kind of growth. Then we can use as a very simple model. If you want to tell your student that this is non-malicious and this is healthy or this is non-healthy, use the teachable machine. You can feed all the healthy images to the teachable machine in one group. You can feed all the unhealthy images or malicious growth images to the teachable machine in the second group, and you can use now, once it has been trained, give it a new image or an MRI image, and it should be able to classify within the image as malicious or non-malicious. This is the simplest way you can actually take it forward. For a more complicated way, if we want to see whether this malicious growth is malignant or not, you may have to have the scan of a person repeatedly over a lot of number of years. So that is going to give you an idea about whether this particular growth is growing more or not growing. So that again is going to give you a different perspective on whether this particular malicious growth is increasing or not increasing. So that if it is increasing, you would be able to tell that this particular growth is cancerous. And if it is not increasing over a period of time, you can simply say this is non-malicious. So this is how AI would be able to learn. Your interface would be deep learning because we are working with image data here, or maybe MRI, the video data. And on the basis of the images, you should be able to now tell, just a minute. So with the data that you have generated, you would be able to tell whether the particular image is a malicious or a non-malicious node. Deepa, is there a follow-up question? Or I hope this was helpful. Okay, any further query? We can take in as many examples as we want to have. I see no further queries anywhere. Thank you, Deepa, for attending and for the query. Okay, one more thing I would like to address to my audience here is that please feel free to ask. There is no question which is good, there is no question which is bad. I learned AI very hard way. I had to ask a lot of questions which were considered very stupid. By the time before asking, I felt that it's very stupid to ask this question. Why this model works the way it is working? Why there is it's not going any further? Why is it that it have to feed in so a lot of data? So please feel free to ask any kind of question that you feel is coming to your mind. Okay, Uday is asking, there is a lot of models in AI, but how can we check the accuracy of data? Okay. Uday, so far from what I understand from your question is you want to say accuracy of data is a domain specific thing. If I have to get MRI data, as the first question came in malicious growth, who is going to tell me, looking at the MRI, जो initial classification था, that this is non-malicious or this is a brain which is healthy or this is a brain which is non-healthy? I can't decide that. There has to be a person, a domain specific person like a doctor or a radiologist who will be able to identify that this set of MRIs are healthy, this set of MRIs are non-healthy. So that domain expertise is which is something which allows us to understand the accuracy of data. Whether the email which I have received is a spam mail or it is a regular good mail, that I only, as a person with a domain expertise, with a very limited domain expertise, whenever I mark a mail as spam, Google understands that this mail was marked as spam, not by one person, but hundreds of people actually marked it as spam. So it understands from the perspective of a collective intelligence of a lot of people that this was spam. So accuracy or correctness of data or how good my data is, that would always be considered by domain expertise. So AI is not only about uh, data anymore. AI is about the humans which actually classify that data as good or bad, or how good is it or how bad it is. So accuracy of data is always a domain problem. So in machine learning, if I am working across mechanical domain, I require a person with the expertise in the mechanical side. If I am working on health problems, I would have to require the expertise of a person who is a healthcare expert. If I'm working on a new drug discovery or a pharmaceutical problem, I require the help from a pharmacy person. Likewise. Uday, I hope that answered your question. We still have a couple of minutes before we close. So, thank you. It was a very good question, Uday. It was very rarely people ask that how do we maintain the good quality of data? Because most of the people are working with AI, they take the data, they feed it, they apply a certain model and then say that this is the accuracy we are getting. But primarily, AI is only as good as the data is. So it's a very good question. Thank you for asking. Any more questions, please? Okay. Deepa is asking, how is the model able to modify its algorithm? Okay, Deepa, I'll walk through the process again. I'll take the simplest example. There is a degree centigrade, there is a degree Fahrenheit, and I wanted to find a mathematical relationship between these two. I keep on feeding my simple regression model or my simple AI model, which is supposed to predict कि इतना सेंटीग्रेड होगा तो कितना Fahrenheit होना चाहिए, या इतनी एज है तो कितना spending होना चाहिए. Algorithm itself is not changing. Algorithm itself remains the same. It's a linear regression model. It is going to find out, okay, given enough data points, what is the straight line that I can plot which covers the maximum amount of these points together. But as long as we keep on adding more points to this space of age and spending, we keep on adding more points. The line keeps on refining. So algorithm remains the same, but data modifies the model. Okay. So the more and more data, the more and more good quality of data that I keep feeding the algorithm, the more and more it keeps on restructuring the model or capturing the relationship between the parameters more and more. Every time I keep on feeding it better data or more data, the algorithm remains the same, but the mathematical model, the relationship which is existing between the parameters, it keeps on changing. So my answer to this question is, algorithm is always static. Model keeps on changing, but the model keeps on changing on the basis of what is the data, how much amount of data, and what is the quality of data that we are feeding to this particular algorithm. All right, thank you. So Deepa says she understands. My job is good, perfectly fine if you are actually able to get this. There can be more questions on the chat window, and I'm loving your questions. They are the fundamental questions to AI. I think, okay. So we have, I'll share my mail ID so that you can, in case you want to put out more questions, and we can close the session afterward. So any more query that you have, anything that you want to ask, anything that you want us to help you with, please forward your queries to sachin.gupta@methodai.com. I'll be very happy to answer your queries. Just give me a relaxation of say a couple of hours, because if I'm busy, then I may take more amount of time, but I do answer all the queries. Thank you so much for having us on this session. Sir, I think we can close.
Hope everyone enjoyed the session, the second in the series. We are grateful to Dr. Sachin Gupta for this informative session, and a big thank you to all the participants of today's webinar. Thanks to Dr. Gupta, many more such webinars are lined up.
Okay,
So
Uday is asking
stay
another
tuned
question.
and stay
How should
safe.
governments and international organizations collaborate to establish global norms and regulations? Uday, this is a very hard fought question, because commercial organizations want commercialization. They want to earn profit. Governments want to regulate AI. But with regulation, commercialization is not possible. With commercialization, regulation is not possible. So both of them wouldn't go hand in hand. At some point, there may be some understanding that yes, we can come to an understanding that this much should be regulated and this should not be. But so far, there is no resolution to this question happening. Right there.
Thank you very much, Dr. Gupta.
We'll be covering more ground in the next session. We are actually covering the entire class 10 syllabus across these sessions, so that, and for the educators specifically, because if you are facing any challenge across any simple problem that you are facing with your classroom for any topic related to AI, please keep sending us feedback or queries so that we can incorporate into our session. I'm trying to get the maximum excerpts out of the new AI book that we have launched, and we are framing the book in a way that it would be more helpful for the educators, because I as a teacher understand that if there is a book available in the market which I can easily relate to and which I can easily take it down to my student, my job is very well done. So I have written the book on the perspective of how a faculty should be able to understand first and then deliver it to their student. So you'll enjoy it. Thank you for having me. You can look me up on LinkedIn as well, and I'll be happy to connect to every one of you.
Thank you, Dr. Gupta. Thank you, all the participants. There are many
Uday,
more such webinars are lined
please
up.
submit a request to Manmohan Malik sir is on the call, and you can make a request. I hope we can definitely send you a copy.
So this is a request to
You
everybody.
have it on the chat window. Reach out to ashish.agrawal@sultanchan.com and you will be getting a copy for the sample. In fact, we are conducting school sessions also for the students and for training the staff members. Sir, I hope we can now close this session with some queries, some interaction, some lovely interaction that happened here. Thanks a lot for joining, everyone.
Thank you very much, Dr. Gupta, and thank you everyone for joining in. So there are many more such sessions are lined up. So stay tuned and stay safe. Thank you.